Hello everyone, this is Archana Neopaney and today I am going to talk about thin film techniques. I would like to thank Department of Physics of Namchi Government College and also Dr. C.P. Khatiwata sir for giving me this opportunity to talk on this topic. So, without any further delay, let's begin. Let us see the aim of the thin film technique. Thin film deposition involves deposition of the individual atoms or molecules on the surface while thick coating deals with deposition of the particles. It has been used to modify the physical and chemical and surface morphology of the materials. Introduction to thin film techniques. The course provides foundation in thin film deposition, emphasize the most used techniques. Modern thin film technology has evolved into sophisticated sets of techniques used to increase performance and aesthetic values of many products and make new functional systems and devices. Definition. A thin film is a layer of material ranging from fractions of nanometer to several micrometers in thickness. A thin film is a thin layer of material that has a different index of refractions than its surroundings. So now let's learn about thin film deposition. So first of all, let's learn what is thin film deposition, why we use it and some methods for it. So let's learn about the definitions of thin film deposition. It is a process of applying a very thin layer of about nanometer to 100 micrometer onto a substrate. Now let's see the types of thin film deposition. Number 1, PVD, physical deposition. Number 2, CVD, CHEMICALVAPORDOCION. So we have physical vapor deposition and chemical vapor deposition. Now let's learn about the uses of thin film deposition. We use this techniques in semiconductors industries, solar panels, CDs, disk drive, optical devices, etc. Let us learn about the differences between physical vapor deposition and chemical vapor deposition. So, in physical vapor deposition, we use from solid to vapor, whereas in chemical vapor deposition, we use from fluid to vapor. In physical, we deposit direct material to substrate, whereas in chemical, we use in mixture form. No chemical is used in physical vapor deposition, whereas in chemical vapor deposition, chemicals are used. Let us learn about physical vapor deposition. Physical vapor deposition is also called PVD. PVD is a thin film coating process of pure metals, metallic alloys and ceramic with a thickness usually in range from 1 to 10 micrometer. So, in PVD, we will need a substrate where we deposit using physical method. So, let us see the diagram. Let it be a vessel and source. Let it be a source material. We need to heat the source material, and after that source material will evaporate and it will stick to the substrate to form a coating. So PVD is also called physical transport deposition. Let's understand better with the help of chart. Source. We need to take a source material, and after that it gets evaporated. After evaporation, the source which we have taken, it might be in solid form or in liquid form. After evaporation, solids or liquids changes into vapor form. After this, the material will get deposited. First of all, it will transport. It changes its morphology, physical morphology. So let's see overall. First of all, we need to take a source which can be solids or liquid. Okay. After that, we need to apply some external heat. After that, it gets evaporated and it turns into vapor. It needs to transport and it deposits in the substrate. So overall, it changes its physical morphology. The vapor phase material can consist of ions or plasma and is often chemically reacted with gas introduced into the vapor called reactive deposition. Deposition of thin film is a process where the material to be deposited is heated to high vapor pressure in vacuum. So, let us see with the help of diagram. For the process of thin film deposition, we need to take a chamber, and this chamber should be vacuum. There should not be any air molecules. Okay, it should be vacuum. VACCUM. And we need to take a material inside this chamber. It is a source material. And substrate, we need to keep it over here. When we give heat to the source material, this will start evaporating and it will stick to the substrate. Okay, and if vacuum is not present over here and if some other gas molecules are present over here, that time when this source material will evaporate, that time it will get stick to the any molecules. For example, if there is oxygen molecules over here, it will get stick to the oxygen molecules or carbon molecules. So the process of thin film technique will not be good. So it is very important to create a vacuum over here. We will also use a vacuum creator like over here. Thermal evaporation uses heating of the materials to form a coating. As we have already learned that heating of the material, source material, is necessary to form a coating. Heating is achieved by various methods including hot filament, electrical resistance, electron laser beam and electric arc. So, as we know that to evaporate the source material, we need to heat the source material. We need to give thermal energy to the source material. So, for that process, we have different methods. Okay, we can use hot filament, electrical resistance, electron laser beam, and also electric arc. And also, we can heat that source material directly. The heating of the materials can be done by electrically resistive heating, and it's called thermal evaporation. So we can heat the source material by the use of thermal evaporation. The heating of a material can be done by electron beam and is called electron thermal evaporation. We can also use electron beam for the heating of the source material. Now let's just see the gist about the classification of PVD. Okay, number one is our number one is our thermal evaporation, and number two is our electron beam evaporation. Now let's learn about CVD. So what is CVD? CVD is a chemical vapor deposition. So CVD is a bottom-up approach for the synthesis of nanomaterials and its deposition of thin film into the substrate. So let's see what is meant by bottom-up approach. It is a process in which we use nanomaterials, small atomic level materials, and we make big nanomaterials out of it. Okay. As we have already studied about PVD, that is physical vapor deposition. So now the question arises, why do we need chemical vapor depositions although we already have physical vapor depositions? The answer for that question is the physical vapor deposition needs a lot of space to perform, whereas chemical vapor deposition can be performed inside a small laboratory also. And also the physical vapor deposition needs a lot of time, whereas chemical vapor depositions can be performed within a small period of time. CVD is a chemical process that is used to produce high quantity, high performance solid material. So CVD is also used in semiconductor industries to produce in large quantities. In CVD, solid material is deposited from vapor by chemical reaction. Now, let us see the differences between CVD and PVD, that is chemical vapor deposition and physical vapor deposition. Definition, differences in definition. PVD means physical vapor deposition, whereas CVD means chemical vapor deposition. In PVD, for coating material, solid form is used, whereas in CVD, for coating material, vapor form is used. The method of depositions is like in PVD, atoms will move for the coating, whereas in CVD, the gaseous molecules will react with the substrate. In PVD, the source material will deposit at relatively low temperature, whereas in CVD, the source material will deposit at relatively high temperature. Applications. PVD is suitable for coating tools, whereas CVD is mainly used for protective coating. Let's learn about the principle of thin film. There are two principles of thin film. Number one, additive or lift-off principle. Number two, subtractive or etch-back principle. So now let's talk about additive or lift-off principle. In the additive or lift-off principle, the pattern generating step involving some form of principal masking agent is followed by counting process resembling the use of stencil. Now for subtractive or etch-back principle. Subtractive or etch-back principle is a process which involves the counting of entire surface followed by the removal of selected portions to form a desired pattern. Now let's see the characteristics of thin film techniques. So they maintain long-term stability and also temperature stability. They have excellent terminal strength. They have linear temperature coefficient, and also they act as strong protective coating with good edge covering. Let us learn about advantages of thin film techniques. Number 1. They have microprocessing. They have low profile functionality with layering. We can save total cost through energy saving, high stability, high precision. They maintain uniformity between neighboring elements. They maintain minimum and uniform floating capacitance. They maintain low noise and wide frequency. Let us learn about disadvantages of thin film techniques. The cost of thin film techniques is very high. We need to be very careful in handling. The reactions of thin film technique is also very high. Less catalyst loading due to size restriction of the film. Extra preparation step is needed. The coating rate is very low. Now let us learn about applications of thin film techniques. The thin film techniques or the thin film materials have already been used in semiconductor devices, wireless communications, telecommunications, integrated circuits, rectifiers, transistors, solar cells, light emitting diodes, photoconductors, light crystal displays, magnetic memories, audio and video system, compact disc, electro-optics, etc. Now, let us see the examples of thin film techniques. Materials such as jewelries, wristwatches and knives are often coated to avoid corrosion. Other familiar example is the household mirror, which typically has a thin metal coating on the back of the sheet of the glass to form a reflecting interface. The process of silvering was also once commonly used to produce mirrors. Thank you.